Climate-related risks for natural and human systems are higher for global warming of 1.5 degrees than at present, but lower than at 2. So basically, we're looking at if the temperature goes up to 1.5 degrees, we're looking at much more significant climate risks than we have at the moment. But if we go to 2 degrees, we're talking about substantially and significantly higher risks again. But these risks will depend on the magnitude and rate of warming, the geographic location, the levels of development and the vulnerability of the place, and on the choices and implementation of adaptation and mitigation options that are used. Impacts on the natural and human systems of global warming have already been observed. Many land and ocean ecosystems and some of the services they provide have already changed due to global warming. I wonder, have any of you noticed any of these in your locality? And this, of course, is before we reach the potential 1.5 degree rise. How great are the risks going to get if we continue on the path that we're on? I think that is the worrying question here. Future climate risks, of course, will depend on the rate, the peak, and the duration of warming. In the aggregate, they are larger if global warming exceeds 1.5 degrees before returning to a stable level. Some impacts may be long-lasting or irreversible, such as the loss of some ecosystems and severe damages to and reductions in biodiversity. To address these climate risks, we need to look at adaptation and mitigation measures, and they are already occurring. Future climate-related risks would be reduced by the upscaling and acceleration of far-reaching multi-level and cross-sectoral climate mitigation, and by both incremental and transformational adaptation. So when we talk about mitigation, climate mitigation measures such as reducing emissions of greenhouse gases or removing those gases from the atmosphere. So things like, going towards green energy and carbon sequestration would be mitigation. Adaptation measures involve the process of adjusting to counter the effects of actual climate change. These will be important issues that you will see going through the whole program, and we will be coming back to them again in detail in a number of the different modules, but in particular on the climate change, on the SDG on climate change, SDG 13. So I mentioned radiative forcing earlier. So in a nutshell, positive radiative forcing means the Earth gets in more energy than it radiates back, and that is the kind of issue that we're talking about. So if we look at this, figure that we have here, we'll see there on the left-hand side is the temperature 0.51, 1.52 degrees, and on the bottom axis we have the dates from 1960 up to 2100. Cumulative emissions of CO2 and future non-CO2 radiative forcing determine the probability of limiting warming to 1.5. So they are the issues that will determine the limiting of that. So if we look here, we can see the squiggly line that runs along there is the observed monthly global surface temperatures. And there you can see that the line 1.5 degrees running across there. And we're trying to project when that will actually occur, or this model is trying to project when that will occur. So there's a number of possible scenarios, and you can see there's quite a wide range in those, because these are, of course, just probabilistic models, so that there's quite a range in the likely outcomes. The first one we look at, global CO2 emissions reach net zero in 2055, so that's what we're looking at, while net non-CO2 radiation forcing is reduced after 2030, so we're reducing the non-CO2 radiative forcing after 2030, and we're aiming for zero CO2 by 2055, which is broadly in line with all the targets that are being set currently at the moment, have zero CO2 emissions by 2050. And that, you will see, is the middle range there. You can see the next possibility there is faster CO2 reductions result in a higher probability of limiting warming. So logically, if we can reduce the amount of emissions quicker than 2055, we're going to get a better result faster. However, if we don't have any reductions of net non-CO2 forcing, this results in a lower probability of limiting warming to 1.5 degrees. Here we come to probably what I would consider, well, I was going to say my favorite, but I'm not sure that's the right term for it. I think this particular slide shows so much. So this next slide is the stylized net global CO2 emission pathways, billion tons of CO2 per year, gigatons of CO2 per year. So if we look at this, I find this interesting and quite frightening curve. If you want to consider it as a curve, if you look on the left-hand side there, we have the billions tons of CO2 per year, and on the bottom axis we have 1980, 2000, 2020, 2060, 2100. You can see that if we want to get to net zero emissions by 2050, which is the line on the right, we are going to have to reduce our emissions significantly faster than they have been increasing over the last number of years. And if we want to do that even quicker, we're going to have to have a very steep curve, a very steep slope altogether, and that is going to present and is presenting huge challenges on a global basis. I think this particular graph says so much about the size of the challenge that we all face. If we want to reach net zero by either 2050 or even before then. This next graph tells another story. So this graph is the cumulative net CO2 emissions. So that is all the CO2 emissions that we have added up together. So we can see there that, again, on the bottom axis is time, 1980, 2020, 2060. And on the left, the axis is the cumulative net CO2 emissions in thousands of billions of tons. Again, I think this is a very telling curve. In 1980, our cumulative emissions were 1,000 billion tons. In 2020, they were 2,000 billion tons, so it doubled in the case of 20 years. That was an average of 25 billion tons a year, 25 billion tons of CO2 per annum. When you look at it in a bit more detail, in 1980 it was 20 billion tons, and in 2020 it was 40 billion tons, so it doubled over the period of 20 years. Again, this is a very telling graph, and you can see the two lines there. The top line is the cumulative CO2 emissions if we manage it by 2055, and the bottom line is if we actually manage it by 2040. You can see there's a significant difference in the cumulative amount, because you've got a 15-year gap between them. A very telling graph, I think. Those statistics are, I think, quite stark. And in the next chapter, we will have a look at the projected changes and the potential impact associated with these various scenarios. Thank you.